All right, welcome everybody. Hello, hello. Welcome to this week's CodamX, everybody here and everybody watching online. Of course, as always, the talk will be recorded and live streamed if you want to check it out later. If you're not here next week, for example, go to codam.nl/CodamX and you can watch it live there. Lorena will introduce our speaker this week.
Our speaker today is a full-stack web map developer with a creative focus. She's currently working at Webmapper as a cartographer and yesterday won the Geo Prestige Award. Today she will take us on a journey through web mapping. Please give a big hand for Niene Boeijen.
Right before you start, I'm sorry, one important thing I forgot. If there are questions during the talk, Niene is okay with you asking them. But please wait until we throw you the Catchbox microphone so everybody can hear you online as well on the recording. Make sure you hold it close to your face so we can actually hear you. Yes? Awesome, thank you.
Okay, thank you. Welcome everybody, and thanks for having me. I'm going to talk about geovisualizations for the web, going beyond Google Maps, because there's way more out there than Google Maps has. My name is Niene Boeijen. My presentation is online. It's a website, so if you want to check it out, all the links in my presentation look like this blue box with the white letters, and you can click on it, and there is either extra technical information behind it, or a nice application or a visualization you can check out. So, I call myself a web cartographer. What do? I make maps. I make online maps, and I make sure my maps are interactive. I develop them from the back end to the front end, so from the geodata all the way to how it's visualized online. And I implement this all through code. How did I get there? When I started studying, I actually did 1 year of art school. After that, I went to university and I finished a master's in geoinformation science. So I really come from a GIS background, which means that I learned how to analyze geodata and do scientific research with geodata. But I started missing the visualization part of it. The maps that came out of the scientific research always looked kind of ugly to me. So I started to look, how can I visualize my data better, and what is better to do than put it on the web where everybody can see it. So I searched for an internship, and I did my internship here in Amsterdam at the Waag, where I learned my first step in making interactive geo-visualizations on the web. And that's where I learned how to make a web page and put my geodata on a web page. From there on, I started organizing map-time meetups, meetup in Amsterdam and Utrecht, which is all about maps. And I got into contact with Webmapper. That's where I'm working now as a web cartographer. Webmapper is based in Utrecht. We're a really small company, just with 4 people. And we make all kinds of interactive maps and geodata visualization. We do this all with open data, open standards, and open software. And our power lies in combining cartography with web technology and GIS knowledge. If you want to check out what I make, you can also have a look at my website, where you can see a lot of different geo-visualizations that I made. I'll also show some of them throughout my presentation. But I wanted to start talking to you about maps and what geo is. I wanted to start with the first law of geography. I really love this first law of geography, and I think it's not only applied to geography, but to a lot of things in life. Everything is related to everything else, but near things are more related than distant things. And to me, it means that friends or family who live close by, you have more relation with than people that live further away. You can see it in the news. The national news always tells you what happens to stuff in the Netherlands, and things about foreign countries always get second place. Also, if there's a disaster somewhere, you always hear if it affected Dutch people before you hear if it affected somebody else. So near things are more related than distant things. And this is also the power that maps have. Our brains organize by location, and we have no choice but to think and see spatial. So a map is actually a model of the real world. It's a simplification of the real world to make sense out of things that happen around us. They lend order to complex environments, and they reveal patterns and relationships to us. Also, a map is actually a collection of geodata. What is geodata and what makes geodata different than other kind of data? Geodata is data with a location. It's quite obvious, but this is also the important part. Geodata, in the most simple form, can exist out of points, lines, and polygons. So a point is just one point with coordinates, and then a line exists out of multiple points which are connected, and a polygon exists out of multiple lines, which exist out of multiple points. This is what we call a feature. So the point could be a feature, and then we have our attributes that go with our geographic features. So the attribute describes what am I looking at. Is the point a tree? Or is it a lantern? Is it an address point? Is the line a road or is it a waterway? And then what kind of road is it? Is it a bicycle road or is it a road for cars? You can add endless attributes to your geodata. Geodata and maps allows us to communicate with each other about distances and locations in a common framework. This common framework is actually what we call a coordinate system. The Earth is round, and we're talking about locations on the Earth. But in order to communicate about the location on the Earth, we make flat maps. How do we do that? Actually, the Earth is not completely round. The Earth is a geoid. It's a really complex shape. So the first thing that we did is we drew a nice ellipsoid around it, so we have a perfect circle. So we have our nice reference for measurement. And then we divided it up into horizontal and vertical parts. And this is what we call a geographic coordinate system. So it's a 3D model of the world, divided with which you can pinpoint on with longitude and latitudes. The most common system that people use is WGS84 system. This is also the system that's used by GPS, and we measure location in longitude and latitude in decimal degrees. Also for web visualizations, GeoJSON is a file format which is mostly seen, is standard in WGS84. But still, we're talking about a 3D model, about our coordinate system. How do we get this to a flat map or a flat screen? This is what we call a projected coordinate system, or a projection. A projection is the mathematical translation from a 3D model to a 2D surface. You can do this in a lot of ways, because making a perfect round shape onto a flat surface is really difficult, and you always have to make compromises on what you're going to show and not. One of the most widely used systems on the internet is the Webmapper projection. It's a really square projection, so as you can see, the whole world fits into a square. The scale is not relevant, so countries can increase or decrease, but shapes are preserved. So what we do if we have geodata, we store it in a WGS84 coordinate system, and we show it in a Webmapper projection. And actually, Webmapper is really, really wrong. Imagine the world as an orange, and you have to peel off the peel, and you put it on a square grid. What actually happens with the Webmapper projection is that the little parts get stretched up to cover the whole square that they're in. There's also a really nice puzzle and movies about why Webmapper is absolutely wrong. But still, we use it a lot on the internet, and Google Maps also has it as a standard. And why is this? It's square, and computers just dig squares, so it's more easy. Yes?
On desktop, Google Maps removed the medicator.
Yes.
The medicator protection was still being used on mobile Google Maps, and on desktop they actually removed it. If you just zoom out, you actually get a sphere of the planet.
Yeah, they made a 3D model of it, yeah. And I think that's really awesome. So we go beyond projections; we can make 3D models of the Earth. Yeah. True.
Yeah.
Awesome.
Another solution that we have. Because still, having a global system might not give you accurate measurements on the local scale. There exist a lot of coordinate system and projections on a local scale. For example, in the Netherlands, we have the Rijksdriehoekstelsel, or the RDNU. which is a local coordinate system. We actually drew a new, smaller ellipsoid in the Earth, the Bessel ellipsoid, and we put our own projection on it. The center point of the RD new system is in Amersfoort. That's where the 0.0 coordinate is. And then they moved it to somewhere in France to the left as a false origin. So you always have coordinates in a positive value, and you cannot get confused on what is the x and the y coordinates. It's a lot, and I think coordinate system projections can be really hard. But I think it's important to know that this is the basics of geodata, and if we talk about GIS, some links about some blogs that explain some more about the projections. So now we know everything about geodata and coordinate system. Are any more questions about this for now? Okay. Then let's continue. Oh.
What would be the source of geodata that you would use to visualize?
You have a lot of different sources. For example, OpenStreetMap, which is data from all over the world with roads and waterways. In the Netherlands, we have a lot of open geodata that the government provides. But I'm going to pass some sources as well later on in the presentation. Yeah. Thanks. So let's continue now how to get a map onto the web. The most simple thing is we have our geodata. We have to put it somewhere on a server, and somebody has to see it in a browser. If I talk about a web map, I'm not talking about paper maps or digital maps, which you can admit, digital maps are something you have on your computer and you do analysis on it and calculate with your geodata. But I'm really talking about maps that somebody views in a browser. And most of the times these maps can be, you can scroll through and pen on the map and zoom in. And in order to make such a map, I drew a picture of the web map universe, as I call it, and I tried to put in all the tools that I come across on making a web map. And it's a lot. Don't be scared. It's just an example that if you ever run into a word or a tool, you can maybe look at this image and see where it's at. But I think the most important thing before making a web map is deciding what kind of map you want to make. And I think that goes for all designing applications or visualizations, is what is the goal of your visualization. And you can have static maps or dynamic maps online. There's even GIS applications, which you can do minor GIS analysis in the browser. You can have real-time updated maps. Have a look at weather maps, for example. But it can also just be images or infographics. If I talk about web map today, I'm mostly talking about interactive dynamic maps. So let's look at this street on how to get your map there. If we look at the web map universe, I highlighted here the part which is all about geodata. And these are kind of tools that I work with. And what I use mostly for my data, so you have some data downloads here as well, is we store all our data in PostGIS, which is a spatial extension on the Postgres database. If I want to visualize my data and explore my data, I use QGIS, which is a desktop application for for visualizing geodata and doing analysis. Esri ArcMap is the commercial equivalent of QGIS. QGIS is open source. Then there's a lot of data formats that you can run into. It's actually not on there, but in QGIS you work with geo packages, and shapefiles is what you use with Esri software. Putting your map on a server, there's different solutions that you can do. There is either serving your data in a server. For example, you work with map server or GeoServer. But you can also cache it beforehand with some command line tools to prepare your data before you put it on a server. And there's also, of course, some cloud-based solutions. And then comes the visualization and the front-end libraries. And we'll see some of these later on in my presentation as well. And when I make a web map, I most of the time go through all these things to make my visualization. So if you're a bit lost about all the capabilities out there. No worries, I'll explain some of them. But also, important to know, I think, is that there is still a huge wall between the geospatial domain and the web domain. So coming from a GIS background, there is the geospatial domain is actually really, really well organized, and there are already a lot of standards out there for exchanging geo information. And these standards work pretty well if you use some GIS software. But using the GIS standards on the web is quite hard to do. It's the language that web developers use is not the same as that geospatial people use, and the other way around. So I think there's still a big wall between it, and it's changing, so it gets less. But if you think that making a map online is hard, it is, because it's not made easy for you. So if we have a look at the geospatial domain, which is on the left, the OGC, so the Open Geospatial Consortium, made standards for exchanging geo information on the web. And the most used ways are a WMS or WFS, which sends over images of a map or even sends over the geographic features of your data. On the other hand, there is also a lot of standards out there that are, for example, developed by Google, and OpenStreetMap, which we call XYZ community standards. And also, for example, Microsoft developed their own standard. And this is more understandable for web developers and also comes from a web development background. So I'm going to talk about these styled web maps. Just gonna have some water first. So I'm going to talk about the way Google Maps makes maps, or OpenStreetMap, and how does this actually work. And I'm going to go back a little bit in history. Before we had maps on the web, we did have GIS software on computers, so digital maps. And then the first time that they tried to put a map on the internet was in 1996. And actually what they did, they just put a really big image of the map online. And this was really, really slow and not user-friendly at all. And it wasn't until 2004 that there was somebody discovered a more quick way of online mapping, and in 2005, Google Maps took over. What is the solution? The solution is tiles. What we do is we cut our really big image up into smaller squares, tiles of 256 by 256 pixels, and we put these in a grid. So they share the same boundaries, and now you can say that you have a seamless map. We call these kind of maps Slippy maps, and it's used by Google and by Microsoft, for example. And the biggest advantage is that all these little tiles, they just load way faster than one big map. So how does this work? This set of tiles actually exists out of zoom levels. So you start at zoom level 0, and you can zoom in all the way to zoom level 22. And then every zoom level has its own set of tiles. So the whole world fits in zoom level 0, fits in one image of 256 by 256 pixels. Then if you zoom in to zoom level 1, you have 4 tiles, and then 16 tiles, and it increases exponentially. I think around zoom level 10 for the whole world, you have more than 1 million tiles already. So that's a lot of images. And I just wanted to show you, if it works, how it looks like. Here you can see a map where the tile boundaries are drawn onto. So here you have one image for the whole world. You zoom in, you have 4, and you zoom in, and it gets divided. So around zoom level 5 at tile 16 and 10, you can see the whole Netherlands in one image. This is also to give you an idea on what the scale is on a zoom level. So the numbers say are the zoom levels that you're looking at. So these tiles are actually just images on the web. I have a URL of a tile here, and if I open that, It's really simple. You just get one PNG image of the map. And if you look at a map, you also only just request the tiles that you look at, and then if you pan through the map, it will request the next tiles and show you them on the map. In code, that might look something like this. This is, for example, URL to request tiles from OpenStreetMap, and then you have the Z and the X and Y position. So the Z is the zoom level that you're at, and the X and Y is the X and Y position in the grid. So it's not the coordinate, it's the tile position in the grid. Oh, you can have multiple threads, so you can have 3 or 4 endpoints to even do quicker requests on images. So you can request 4 or 3 at the same time. So this is how it looks like. You have your big bucket of geodata. Somebody decides the styling, for example me, and you render this. So you tell on every zoom level what kind of color and what the line width and the size is going to be. And you render this and you put that on a big cache on the server and you have your tiles. So styling these tiles is a lot of work. And this is what I do as well. So I style per zoom level all the geodata that's there. So from water to buildings to roads to address points to any kind of points of interest on the map, you have to decide on how it's going to look like. And for raster tiles, you can do it in SLD or map file syntax. To give you a little bit of idea, SLDs is one of these geo-spatial domain standards that is not really web developer friendly. It's based on XML and is a really an elaborate language to, you have to write a lot of stuff just to assign a color to a line. And this is, for example, one of the map files that I wrote. And it just is a lot of rules per scale, per data set, per layer, what the style is going to be. But it gives beautiful maps. So this is one of the maps that I made for the municipality of Amsterdam. It's also in their data portal. And I wrote these styles with the map file that you saw in the previous slides. And then I also made a gray style for them and a light style for them. So that means I had to write 3 times the styles. And it's not only about changing colors. Sometimes also the roads are bigger because in the colored style, the roads may appear more prominent than, for example, in the gray styles. There is a disadvantage, though, to raster tiles, because what you do actually, you just flatten all your geodata into a PNG image. So you lose all the information about your features and about your information, your attribute information that you might have in your geodata. Also, there is no interaction possible anymore on the client side. There's no information on the features. And so if you want to know what you're clicking on, you actually have to send the coordinates on where you click to the server, and there it has to check in your geodata what feature is on that coordinate and send back the answer. So we can visually interpret these pictures to see that, hey, the green area, that's grass, and this line is a road, but the computer cannot anymore. Another big disadvantage is that every visualization means making a new tile set. So for all these 3 visualizations, we had to generate 3 tile sets with all these images again. And luckily, this was only for the municipality for Amsterdam, but imagine doing this for the whole world. As I told you, zoom level 10, you already have more than a million tiles. You have to put those images somewhere. So although they're really small, it gets big if you make a whole tile set. Vector tiles, that's the next step. And actually, this is a new technology, and I think Google Maps uses it already for a lot of years, but it's been around in other areas, maybe now 3 or 2 years. And I really wanted to show you that. I work a lot with vector tiles. So what is the difference? What we saw before is what we call raster tiles. They're based on images, so they're built up out of pixels. Now we're going to look at vector tiles, which are made out of features. So really the geometry is contained in the tile. How does that look like? A vector tile is exactly the same as a raster tile in size, so it's also 256 by 256 pixels, and it's placed in the same grid as the raster tiles are, like we use the same schema. But the geometries are compressed and are binary compressed, also with protocol buffers, so they get really small. Then there's also no styling information in the tile itself, so there's no colors. It's just simplified geometries. How does this look like to make vector tiles? We have our big bucket of geodata. You process it, you decide which data is going to be in which tile and which zoom level, and you cache it somewhere. To be able to visualize and render tiles, that happens on the client side in the browser, but you'll have to assign some of the styling in the browser as well. So this is different from the raster tiles, which the styling and all the rendering happened beforehand. This makes it really quick, as there is rendering on the client side and not on the server side. So they're really, really quick to generate. What's also a great advantage is that you can have a custom style in the browser. So you can have one tile set, one vector tile set, and you can have an endless amount of visualizations on top of it. Before with the raster tiles, we had to really copy all the tile sets. Now we can just have one tile set and have multiple visualizations. Vector tiles are really fast, and because they're rendered in vector, it gives also high resolution maps. And what's really awesome is you can add some attribute information to your feature in your tile. So you have direct access to what your feature is. So if you click in the browser, you don't have to send it all the way back to the server. You just have the information already there in the client. Vector tiles are rendered with WebGL in the browser. WebGL is rendering with the help of your graphic processing unit. And the functionality that comes with this is that you can have a little bit of a 3D effect in the browser as well. So you can rotate and tilt the map, which was not possible before with the raster tiles. You have really smooth and infinite zooming, so you can also do overzooming. If you overzoom on a raster map, you eventually see pixels. If you overzoom on a vector map, you'll always see the vector. And I think WebGL is already supported in a lot of browsers. So how does this look like? This is the same map from Amsterdam that I remade, but then in vector tiles. And as you can see, it just works pretty fast, and you can rotate and tilt the map. This is to give you an idea on how it visually looks different on the client side between raster tiles and vector tiles. So on the left, if you focus on the labels, you really see that they change step by step. That means that you move from one zoom level to another. So you go onto another tile set, and this makes it jump the labels. While on the right, if you look at the vector tiles and you focus on the label of Amsterdam, you'll see that it has a kind of smooth interpolated size. And what's also really fun is that you can have a little bit of 3D. So I made the Bach, which is the buildings of the Netherlands dataset, into 3D. And you can extrude all the buildings on the height. And having so many features in your browser and having them extruded in 3D is incredible, because there's so much data actually that you can get into your browser. And if you look at this map, you can visit the application if you want. You might notice that if you zoom out and you get more and more features into your screen, it gets slower. But this was not possible before. So how does it work with vector tiles? You have your tile set, and you need some styling information and also some information for fonts and extra images. Styling, as I showed you before with the SLDs or with the map files, that looked really hard. Styling vector tiles according to the Mapbox styling specification is done in JSON syntax. And this is way more developer friendly and better readable, because JSON is a JavaScript object notation. I don't know if you worked with that, but probably if you did, you can just easily read this. So this is, for example, a style that I made, and they get long as well. But the fun thing is that they're better to interpret than SLD, for example. Better human readable also. Oh, yeah. And what is fun, because it's based on JSON, you can also add some interactivity with JavaScript. And I really love that. So I'll show you some examples. So this is a map that I made, and actually I have some CSS blend modes on it as well. And I did some fun coloring it in. But also this one, I put a random stain on the map. A coffee mug stain, as you can see, it's here. And it stays on the map, but every time that it goes out of the screen, it's redrawn somewhere else. And yeah, I know it's there. So next to the crazy possibility to have on styling them, it's also really fun to add in random stuff. And oh no, my clicker's not working. And this one as well, I actually put in random hot air balloons. So every time you change the map, you get some random stuff rendered on top of it. And okay, fun, so I showed this, and then I got the questions, can't you just also increase the labels? So that's also what I did. And I think this is really the power of vector tiles. You can change the style afterwards in the browser. So you can add all kinds of functionality as increasing the font size of all your labels for people who need reading glasses. Don't know why it's not working. Maybe because I clicked in the browser. Okay, I already talked a little bit about front end, but to wrap up the whole picture of how to make a web map, we now arrive at the front end. And that's what you do with JavaScript. And that's where everything comes together. You put your tiles, your content, and interaction together. So we have our tiles, which could be raster, vector tiles. You can add some extra data. So it's also really common just to add extra geodata on top of raster tiles, some extra information, and then it just comes all together with JavaScript in the browser. And a map is a lot, a web map. It means that you can have zooming and panning and clicking. You can have some interaction. You can have some map events. You can add pop-ups and markers. You can add some additional data, and then we have our WMS and WFS, for example, again, which you can all combine in the front end in your JavaScript library. So there you have all the JavaScript libraries that I know of that you can make web maps with. There are a lot of them. So when to use what? And I wanted to show you a little bit on what I know when to use which kind of JavaScript library. So did you ever work with D3? Anybody? D3 is for data-driven graphics. So it gives you a static map. I'll talk about this a little bit more. I don't know what the time is at the moment. 38, okay. Turf is a library which you can do GIS analysis, geospatial computation in the browser. So that's also what I used to draw random points in my maps before. A leaflet is a JavaScript library which is used a lot because it's really simple, it's lightweight, and you have really quick raster web maps. OpenLayers is kind of a leaflet, but then more elaborate. So there is way more functionality and plugins available if you want to have a web map. The ArcGIS JavaScript API works great, and especially works great if you work with Esri software. You have maybe clients that have Esri servers, because putting Esri data and servers into Leaflet or open layers is harder. Mapbox.gl for vector tiles. Mapbox actually developed the vector tiles, so that's the way to go. Tangram is an alternative to the vector tiles. Carto and Mapbox also have cloud solutions. And then, of course, the Here Maps and the Google Maps API, for example. And what Google Maps does great is navigation, for example, and commercial information. But they don't give you a lot of freedom in changing the styles or changing the look of their map. But they do a good job. I use Google Maps all the time for navigation. I actually found my way to the college here with Google Maps. So, yeah. I think these considerations just decide what kind of technique you need to use. So considerations could either be if you want to use open source or closed source libraries. Because if you use Google Maps and you put a Google Map on your website, they also track your users. So if you don't want that, you can maybe better go for Leaflet, which is completely open source, and you don't have to use third-party softwares there. Do you want a raster or a vector map? What kind of interactivity do you need? Leaflet is really great for just plotting a little map and put one marker on it. But if you want to do some GS functionality and you want to draw polygons and do calculations, then open layers might be better. And also the amount of data you have to show in your browser. So if I have enough time, I just wanted to highlight these 3 libraries, and otherwise I can skip it. Yeah? So I'm just going to talk a little bit more about Leaflet and Mapbox and D3, because I think these are the most interesting for you as well if you ever want to make a map on the web. Leaflet is an open source JavaScript library. It's really simple and easy to use. If you go to their website, it just dives right in to make your map on a website. And it's really lightweight, so it's perfect for mobile applications. It can be extended with plugins. There are a lot of plugins available. And it's really well documented. And if you just need a simple map on your website showing you where the location of a company is, this is just the way to go. What does it not do? So Leaflet does not provide you the data, and it also does not provide you the base map. So it doesn't provide the raster tiles. It's a framework which makes sure that all these things come together. So what we most of the time have in Leaflet is we use raster tiles as a base map, so background map, and then on top of it we add some data layers or feature layers, for example a marker where your office is, or some small buildings that you want to highlight, and you put them on top as vector data. If you're interested, there is a link behind this on all kinds of tile providers where you can just find raster tiles freely available, but also, for example, PDOK, which is the Dutch governmental map, map giver? Provider, yeah, there you go. They also have a lot of raster tiles available, which are all based on Dutch open geodata. How does that look like in code? They told me that you wanted to see code. So there you go. You just make a Leaflet map instance. You put the center coordinates of your initial view in it and the initial zoom level. And then you provide a tile layer. So here you can see that URL again with the Z, with X and Y parameters. You have some attribution, which is always like the little stuff on the bottom of the map. And then you add that to your map instance. And this is actually everything you need. And the Leaflet library, of course, to have a little map on your website. On top of this, you can add data. Here you can see an example on how to add a WMS layer. So here we use some Dutch CBS data, some statistical data. And as you can see already, it's much more complicated already to use the WMS. Leaflet is great with different projections. So if you ever need to make, for the Dutch government, for example, a map in a projection of the Rijksdriehoekstelsel, then Leaflet has these nice plugins to work with and change the projection. Actually, the government in the Netherlands is obliged to show their data in the Rijksdriehoekstelsel. And this is how it looks like, just a simple map. Next, Mapbox.gl. Actually, Mapbox.gl is what I use to make the interactive maps with. And it's developed by Mapbox. Mapbox is a commercial company, but they provide all their backend tools as open source. So you can just plug into their API and use their tools as well. But they also have a really commercial front to all their applications. But I use the Mapbox.gl JavaScript API, and then for the styling, they have a Mapbox style specification. You can find them behind these links. And what does Mapbox do? You provide your tiles, you provide a style, you provide information about fonts, and then Mapbox renders this all in the browser into your interactive map. This is how it looks like to code a map. So it looks almost the same actually as the leaflet one, but now we make a Mapbox.gl map instance. We say to which container it has to be linked in your browser, the styling object, and also the initial zoom and center. And next to that, you can also put in the tilting and the rotation of your map. And the stylization, as I showed before. So what might be confusing if we talk about layers in leaflet, we talk about every kind of data layer that we add to the map. But if we talk about layers in Mapbox.gl, it could be a data layer in the tile, or it could be a style layer in the front end. And this might be confusing if you start to work with different web mapping libraries and you're like, what are layers? It is confusing. Where you can get vector tiles, Mapbox has some vector tiles, but MapTiler is, for example, an alternative that provides you with vector tiles for all over the world, but also local tile sets. OpenZoomStack is actually the local vector tile stack from the UK. Esri also offers vector tiles to their customers. And then we developed Cartico, which is a tile set for the Netherlands. That's what we developed at Webmapper ourselves. And we're still waiting actually for the Dutch government to provide their maps in vector tiles as well. But they're not there yet. So what do you use Mapbox.gl for? If you want to have a customized background map, if you want to have interactive data, and WebGL rendering. So you can make these kind of maps with it. Then really quickly about D3. D3 stands for Data-Driven Documents, and it's a JavaScript library to manipulate data into the browser. It binds data to your website. It's really fast. It's based on HTML, SVG, and CSS, and you can make dynamic interactive graphics with it. And the graphics are rendered as SVGs, you can, how do you say that? It's a mathematical representation of image, but you can also change the properties behind it and visualizations based on your data. So D3 is not a Slippy map creator, so it's not about the zooming and the panning. It really makes a static image. It's not based on tiles, but it mostly what D3 actually is used for is to make charts or tables or interactive data infographics. But also for maps, so you can make interactive maps, interactive graphic map presentations. And also D3 has a lot of different projections and coordinate systems. So what you use in D3 is actually the D3 GeoPath to transform your coordinates, your geodata, into screen coordinates. And for example, you use the GeoJSON and TopoJSON as input geo files. So, for example, you can make a nice map, and then if you hover over with the mouse, the colors change, and you get some information about it. You can add some graphs next to it, which are based on the same data. There's a lot of examples online. So you ever feel like trying? I have some workshops online, so check out these URLs. There is some workshops about how to work with Leaflet, Mapbox.gl, and with D3 to make maps with. So I think we talked about a lot of tools in the web map universe. As you can see, the front-end libraries, which we talked about, the tiles that we talked about. And then, of course, data, and these are some tools which can generate vector tiles or raster tiles. And I hope I didn't scare you. There was a question there.
Awesome. Well, first of all, that was the end of the talk? Or?
No, not
Oh,
yet.
sorry.
No,
My
but he has a
bad.
question,
Well,
so
we'll do a question. There you go.
if there's time still. Though.
So like,
Of course.
when you're using vector tiling, what if like a single building is on the edge between two vectors? Is it like in both vectors or in one of the vectors?
In the tile, you mean? Yeah.
Oh, yes.
Yeah. So what you actually do, there's a buffer also around the tiles to have polygons which are at the edge of the tiles. So yes, it's in two tiles, but it's also overlapping a little bit, and that gets solved at the front end how to style it.
All right, thank you.
Yeah.
A quick second question. One of these example maps you showed, was that by any chance a map showing how old buildings are in the Netherlands?
No, they were colored on the height.
Okay. Otherwise, I would have seen that map on Hacker News, but oh well.
Yeah, I know which map you mean, and that's the map from the buildings from the Waag, made by Bert Spaan.
Yeah.
And actually, that was the reason that I wanted to do my internship at the Waag, and I also did my internship with Bert Spaan, so I learned from him. Yeah.
Yeah, cool.
Thanks. I have a little bit more, if that's still possible. I could go through it.
How much longer?
Okay. Because I just wanted to have a bit more of a vision, and I think maps are everywhere these days, and it's great. You see a lot of maps, and there's also there's so much open data available and so much open source software available to make maps with that it's possible for everybody to make maps. And new technologies also mean that maps go beyond a static map. Maps are dynamic, they're responsive, they can even be intelligent. So the realization that a map is more than a design is something that we really have to think of. A map is an experience, so we also have to think about the user experience and the interactivity that a web map has these days. And for cartographers, I think this is a new challenge, because as a cartographer, you used to think only about map design and not about the interactivity afterwards. And I think for the developer also, there's a challenge to think about the cartography, and making a map is so easy, technically seen, that's also easy to make a wrong map. So web mapping is more than design. It's about speed, about scalability, about data-driven visualizations, responsive designs, and even personalized maps. And if you look at Google Maps, it already personalizes your map. So based on your preferences, on what you do on the internet, Google changes the map. So if you visit a lot of beer pubs, for example, your Google Maps might show you more beer pubs than somebody who visits a lot of pet shops. And I think it's incredible that this is possible, technically seen, but it's also a bit scary. But there are some people that say, how long will it take till we have one universal map? So one map, but that's personalized to everybody. In general, we can just say that cartography is cool again, and cartography is the new code. There is so much mapping going on, and mapping is the future. It's not a niche anymore, which it used to be. It's about mass consumption, about open source software and open data. So the skills, and I think this is for a cartographer, but also for a web developer, the skills that you need to make a web map is about finding and manipulating geospatial data, about designing a functional and attractive map, but also thinking about the interactivity and the user interactivity controls that you need to operate a map. And then in the end, you have to implement this all through code, because data is updated so many times that you have to code your maps these days to get it automated and up to date. And this is the challenge for web cartographers and for developers. And I think for developers, and I assume you're all developers, I think making a good map is also thinking spatial and learning a little bit about cartography. And why do I say this? Is actually all maps lie. And it's super easy to lie with maps and super easy to make a wrong map. I don't know if you heard the story about Trump. He added an extra line to this map because he was convinced the hurricane prediction was going to hit this state, but then the scientists didn't put that on the map, so he just added it to the map. And it's a weird black thingy. But even he lies with maps. So a map is really powerful, and you can visualize a lot of data in a quick way, but it can be inaccurate and misleading. And this is also a great example about 3 maps showing 3 different subjects. So the site users, subscribers to Martha Stewart, and then eventually it just says it's geographic maps, which are basically just population maps. Where do people live? Or you see a lot of maps these days who just based on somebody filling in some nice words on the map. I think these kind of cartoons you see a lot. If you look on Twitter and on Facebook, you see a lot of maps coming by, and check the source and what's really on the map. So there's a lot of power in maps, and also a lot of power in beautiful maps. And actually, I wanted to go through a few few mistakes that you make really quickly. But I think the time is kind of out of time.
We're a little bit over.
Okay, I'll skip these, but it's actually really important. Oh yeah. Yeah, well, if you can show anything, like just this is a point cloud, and it says data journalists discover a dangerous network. Well, just if you that's if you torture your data long enough, you can end up with these kind of maps. And I think it's for all data visualizations. It's really important to think about what you're visualizing and how you're doing it. And cartography is actually also inherent to power. And if you look back into history, the persons that were deciding on what is going to be drawn on the map actually decide who owns what land. And as a cartographer, you have a lot of power. If you're not on the map, you're forgotten. If your company is not on Google Maps, you're not findable. So maps do have a lot of power. So making a map means you have a lot of power. So be careful. Okay, I'm going to wrap up with the future really quickly. And some people say that maps are going to be redundant. So maps will be dead. If we have self-driving cars, we don't have to look at the map anymore. And if you look at those blog articles, it's really interesting to read about it. But are maps necessary? And now it's stuck again. If you look at planes, for example, there's always a nice functionality in your screen to follow where the plane is. And this is actually one of the most used functionalities on a plane. So just sitting in a plane, you don't have any control on how it flies, but people always want to know where they are. And I think this shows the power of maps, that we always just want to know where we are. And I think even with the self-driving car, there will always be work to make maps. And I don't know, people just love good maps. And I love to make them. So I hope we can still keep doing that for a long time. Anyway, thank you.
Thank you very much. We'll have some time for questions, if there are any questions. I already see a question here. We'll quickly go to David.
Hey Niene, my name is David. I'm the director here at Codam, so I'm really pleased to have you for this talk. That was amazing, really inspiring. My question is pretty simple. I have a decent background in programming, and let's say that I want to switch career and work in the map industry. What kind of knowledge would I lack?
That was the first part of the presentation, learning about geodata and coordinates. And thinking spatial, I noticed that thinking in data organized in a spatial way is not that common. So I studied GIS, and from there, for me, it's really normal. But sometimes when I have to explain what spatial calculations are to other people, I notice that they just do not understand. So yeah, learning about GIS, actually, yeah.
Thank you very much.
Thanks for the presentation. I had a question because if you now use Google Maps and you see the route on the map, is that just an extra layer on top? And is the image always the same, or does it work a little bit different?
Routing is a whole separate thing actually then from visualizing data. So the background map of Google stays the same, but you give into coordinates, and probably this is sent to a server somewhere where there's a routing network, and they calculate the best route options for you over a network. So you really have to have a network on your data, which shows you the speed or the time that it costs to travel. And then probably the server sends you just back a line and the information about how long it's going to be. And that's what is visualized again in front end. So doing routing is, that's also if you use Google Maps, they offer you as a service as well to use the routing functionality. But it doesn't come with leaflet or open layers and that kind of libraries. Okay. But you can build it also yourself. You can download OpenStreetMap data and build your own routing databases. Yeah.
Thanks.
Question?
Hello. You said you started from art.
Yeah.
And how come you passed to maps or maps design? Does it have a lot of things where you can apply your artistic part, or how did you?
Yes and no. So I changed from art school to university because I just wanted to learn more. And art school is really fun, and you learn a lot about art and about yourself on a personal level, but you're not challenged technically. So I went to university, and that's where I studied land and water management, and we got some GIS courses in that. So I did my master's. And what I love about GIS is actually the combination between the technical and data and then visualizing it. Because the output of working with geodata is always an image. And that's where the creativity can come in. And that's also why I love the vector tiles, because you can have a lot of freedom with visualizing them and a lot of creativity. So yeah, that's when it comes back. But yeah, I would love to do more art visualizing projects still, yeah.
Thank you.
I think we have time for another question. No?
And that's it.
And
that's it.
Well, if you want to still check me out online and follow me or get in contact, or if you ever want to make a web map and you have questions, you can just reach out to me and I can help you along. So these are some of my email address and my links.
Thank you all for coming. There's more information about the next talk on codam.nl/CodamX. See you next week.